Okay, we have gone through all three phases of the tissue response to injury. And so now we're really going to focus on what are some of those consequences if this process does not move through in the way that it's supposed to. So again, what are those things that we could hopefully potentially help with, or what are those things we want to be aware of and kind of on the lookout for? So the first part of this is going to focus on the consequences of the injury in that secondary injury that can occur, what does recurring inflammation mean, and what is chronic inflammation? Because sometimes they get put together and they're actually different. So first off, secondary injury. Secondary injury is actually one of the biggest areas that we can hopefully assist in if we do it properly and if we follow some good evidence-based regulations. So remember, the primary injury we've already talked about. That's what happened. So that's the ankle sprain, that's the hamstring strain, that's the torn ACL. Okay? Secondary injury occurs as a result of actually usually the inflammatory process of the primary injury. Okay? So let me explain that. We have two ways that cells that were not damaged in the initial injury, so not those ones torn in the hamstring strain, not the ones torn in the ACL, the tissue around that, the cells around that. Two ways that those cells potentially get hurt or die. The first one is called enzymatic. And so enzymatic, that death results from enzymes of the dying cells. As those dying cells get ripped apart and open up and die, these enzymes are released, and those enzymes are toxic to healthy cells. Okay? So as cells die, they will kill off more cells. So this is really important that the inflammatory response cycle starts, right? We need to get the phagocytes in that area that will eat up all these enzymes so that they don't kill off more healthy cells. Okay? So enzymatically, there's very little we can do except to, again, kind of facilitate the inflammatory response cycle. Okay? Also, again, this is another thing where the larger the injury, the larger the chance of secondary cell death, because the more cells we have dying, okay, from the primary injury, the more chances these enzymes are floating around and that they'll go and harm others. Okay? So that's one. The second part is really where our focus comes. And the second part is actually what has started a lot of controversy in sports medicine. But again, it's from people not understanding the use of a modality. So let me explain. Metabolic. Metabolic secondary injury is where, because of the injury and because of the inflammatory response cycle, okay, so remember back to all of our steps in the inflammatory response. We had that vasodilation, which slowed down the blood flow, which we said if that hangs around, that leads to stagnation and stasis. We had increased cell permeability and margination, so we had this influx of fluid going into the exudate, okay? And so we were creating swelling. Well, what happens is that swelling and that debris doesn't allow for the normal transport of nutrients and oxygen. Okay, so the process itself, the injury as well as the response to that, slows down kind of all the other normal activity that is supposed to happen in all this living tissue. And so other cells that are not directly injured begin to die due to the lack of oxygen. It's what we call hypoxia, okay, low oxygen levels. They also can't get nutrients, so inadequate fuel delivery, as well as waste removal. Everything is focused on that injury, and transportation is really limited in and out of the injury site. Okay, so again, thinking of that disaster situation that we talked about, there's some sort of natural disaster. Everyone's really focused on getting in there to help. But now if there's a town beyond where the accident was, beyond where the site was, they might not have been injured or affected, but now they can't get transportation for food or, water or, vital supplies because of everything that happened on the other side. So even though they weren't injured, they are secondarily injured, which is the metabolic injury. Okay. Again, the bigger the primary injury, the bigger chance of metabolic injury, because then the bigger area that's affected, more swelling is going to occur, more damage to vessels. So how do we help this? Okay, what do we do for metabolic? The number one thing we probably do for almost every injury, and again, this is where confusion happens, we use cryotherapy. We use ice. But ice does not remove swelling. We tell our patients this all the time. We tell ourselves this all the time. We say it. It's not true. What swelling or what ice does in an acute injury situation, so we're talking within the inflammatory response cycle, during those first 24, 48, 72 hours. Cryotherapy is meant to decrease the metabolic needs of the healthy cells. So think of, sci-fi where they freeze someone. Captain America, right? He was frozen in some sort of iceberg or whatever. Okay? They freeze the body tissue and then regenerate it some other time later. But by cooling the body, they decrease the demands, and supposedly that will keep someone alive in scientific, or sci-fi movies. What we do is the same concept. We put ice on an area, decrease the tissue temperature and the cellular temperature, and that decreases metabolic demands. We know heat and cellular activity go hand in hand, right? Heat is a byproduct of cellular activity. If cells and ions and molecules are hot or warmer, they bounce around more and have more energy. Cells have more metabolic needs when they're warmer. So we actually put them in this kind of suspended state of animation, okay? Decrease the cell temperature, and they don't need as much oxygen, and they don't need as many nutrients, and they don't produce as much waste. So they can survive longer while the rest of the inflammatory process takes place in the primary injury location. So they don't die. And then when time comes that the injured part is stable enough that normal transport can happen, the temperature raises and those cells can be healthy. That's if we do it right. People do not use ice appropriately. To do this, the tissue temperature has to constantly be decreased essentially for 48 to 72 hours. That means, and we'll talk about this when we get to cryotherapy, but that means constantly having ice on and ice off, and the ice off only long enough that we don't have tissue damage, but not long enough that the tissue temp rises. People don't use ice appropriately. But when done right, it can significantly help in this metabolic secondary cell death. And again, think about that. It has no effect on the primary injury. The ice does not have an effect on the primary injury. It has effect on the secondary injury. So we're not removing the swelling that's currently in the area. We're not healing the tissue that's in that area. That's going to happen anyways through the inflammatory response phase. What we are doing is limiting the overall effect of the injury. So we had primary, and if we were going to see something through, not intervene at all, when we would think about the total effect of the injury, we'd have primary plus secondary equals total injury. Primary, we can't do much about. That happened. Secondary injury, by putting ice on and doing some of the other things that we're going to talk about, we can eliminate or really keep that smaller. So then total injury is smaller. There's less total swelling because we didn't produce more swelling because we didn't kill more cells. It's a total flip in how we think about ice, but it's the right one. And when we don't think about ice that way, that's where we get this controversy that we've seen in literature lately about, well, what does ice really do? Ice is not effective. Ice is not effective to the extent that we think it should be later on in the injury cycle. It is super effective during the acute inflammatory phase, to the point that we can't really study it very well because researchers really think, and institutional review boards, that it's such knowledge, it's such a given right to give someone some ice after an injury that it'd be cruel and unusual to not give them ice. So we can't put them into two groups and say, you're going to get ice and you're not going to get ice. That would be considered, a danger to human patients and human subjects, and that's not allowed. But again, we have to know why we're using it in order to use it properly, in order to actually see the results. Okay, that was my little soapbox there on ice. It's super fun, I know. Okay, recurring inflammation. So secondary injury, again, part of the larger scope of the total injury that we have. Another side effect that we could have is recurring inflammation, which is where we had the acute inflammatory response. We're moving forward. We have our increased cell permeability, margination is happening, phagocytosis, but we get a new incident of an injury. So we reinitiate the acute inflammatory cycle before it was over, before the previous episode had ended. So why do we think this might happen? Why do we think this could happen? And I'm going to have a little, this is another one like the number one modality. There's going to be a little question for you to answer, and we'll see where we end up with. But think about how we would reinitiate the acute inflammation before the previous injury, the previous inflammatory phase has moved on. And when you're thinking about those reasons, think about how we as healthcare providers can help that. So we'll come back to that one. Final one we have is the chronic inflammation. Okay, so recurrent inflammation was when the acute inflammatory response cycle got reinitiated before it had completed. Chronic inflammation is a little different. It's when acute inflammation doesn't respond sufficiently. So we go through the whole inflammatory response cycle, or I should say, we start the inflammatory response cycle, but there's never really enough to really push it along to the point that we don't actually eliminate the cause of the injury. And we don't eliminate that stimulus that started sending off the chemical mediators. And if we've sent off those chemical mediators, they're still doing some of their job, but there's just low levels of them in the area. We need a lot of them. We need a lot of histamine, a lot of bradykinins. We need everything to start all that rest of that process so that the vessels dilate, so that the cells, membranes become permeable, that margination occurs, that we attract phagocytes to the area. But if we just have low levels of them in this area, they're just annoying, right? All those bad side effects, the irritation of the nerve fibers, the redness, some swelling, the pain, all of that we get without all the positive benefits, okay? So they're not in large enough amounts that neutrophils, macrophages, lymphocytes, fibroblasts, plasma cells, all the helping cells, the cleaners, right? These are our cleaners, our builders. None of those are really in the area. Just the annoying chemical mediators, the ones that we tolerate because all the other good stuff happens because of them. So what happens is your body's not meant to have those chemical mediators around all the time. And they actually start to break down tissue even more. And they damage connective tissue, but they damage it kind of so slowly that, again, we don't initiate this inflammatory response cycle appropriately. So we don't actually heal, we just decrease. So we get necrosis and fibrosis, and it prolongs healing in the area. So we get more scar tissue, and this is usually due to overuse and overload, cumulative microtraumas. Not enough to say, I'm injured, chemical mediators come, start the cycle, but just little overloads over and over and over again. Just keep sending just a few chemical mediators into the area. And it actually is a problem. So it's really slow, it's really vague. One example I always like to talk about is those people at a party that just won't go away, right? So you had a party, super fun, it's time to clean up, okay? You're ready to clean up and go to bed, and there's 4 or 5 people just hanging around being annoying. They're not helping. They're not helping clean up. They're not helping to end the party. There's not enough of them that the party's still going and you're still super excited. They're just annoying and you want to kick them out. But they won't leave. There's no one else. They're not calling other people to come. They're not calling anyone to come pick them up. They're just hanging out, and it's just annoying. And that's chronic inflammation.